What's kind of interesting here is for PhD students or, early career researchers, doing reviews is actually a pretty common task. But like you said, even if you aren't doing that formal review, just knowing how it works, it's a massive shortcut to being well informed. It trains your eye to see a paper's real value, or sometimes the lack of it.
Okay, so how do we get this evaluation superpower without, spending years doing PhD reviews?
Well, it actually boils down to something surprisingly straightforward. It's about systematically answering just 5 critical questions. Think of them as your toolkit for taking part in any research paper. These questions target really specific aspects, making sure you get a full picture of its quality and its contribution.
All right, let's jump into the first one then. This feels like maybe the most fundamental. Is this research actually important? Is the problem the paper's trying to solve? Is it real? Is it meaningful? Does it tackle something pressing?
Yeah, exactly. Importance is step 1. And to gauge that, you got to ask, who really benefits from this? Think about practical implications. Is it useful for industry, for other academics, maybe society more broadly? What's the bigger picture impact? How does it push knowledge forward or help solve, real world problems? Take the example from the source material. A paper proposing some new data processing algorithm. It needs to show why it's needed. Does it fill a gap? Does it improve things in a way that actually matters to people doing the work? And sometimes the real importance isn't even what the authors state up front. You might need to read between the lines a bit.
Okay. So where do you look for that?
Well, my advice is head straight for the introduction and the background sections. That's where authors should be laying out why the problem matters, what the potential impact is. If a paper kind of stumbles on this first question, if it doesn't convince you it's important, well, it might just lack relevance, right?
Yeah.
And that immediately lowers its value, no matter how clever the rest seems.
Okay, that makes sense. So first hurdle, importance. If it clears that, what's next? Because I guess even important problems might already have solutions, right?
Precisely. Even if it's an important area, the study needs to offer something new to be really valuable. And that brings us straight to our second key question. What's the novelty? Is it actually new?
Okay, novelty.
Yeah.
How do we check that?
For this, you absolutely have to dig into the related work or literature review section. This part is critical. It's where the authors are supposed to place their work in the context of everything that's come before. Have they done their homework? Cited the relevant stuff? And crucially, do they clearly explain how their research is different or how it builds on what others have done? You also need to look at the contribution itself. Is it a genuinely new method? A new way of thinking about something? A new application? For example, if a paper says it has a new machine learning model, that related work section must compare it to the existing models, point out what's better, what's different, what's novel, and the different kinds of novelty too. Is it a huge leap forward? Or just a tiny little tweak? That's a good point. Incremental versus groundbreaking. Exactly. A novelty that just sort of rearranges the furniture isn't as exciting as building a whole new room, if you see what I mean. If the authors don't do a good job distinguishing their work, yeah, that definitely raises a red flag about originality. Reviewers often double-check this themselves doing a quick literature search.
Right, got to make sure it hasn't been done before, or that the new twist is actually significant. Okay, so it's important and it's new. What's next? This feels like where we get into the nitty-gritty.
You got it. Now, we hit the absolute backbone of credible research. The methodology. How did they actually do the research? Is the method sound? Rigorous, appropriate for the question they're asking?
This raises a big question, doesn't it? Can we actually trust the results if the how is flawed?
Exactly. Trust is built here. So you need to look at a few key things. First, the data. Selection and quality. Did they use the right data or experimental setup? Is it relevant? Like if you're studying social media trends, your data needs to actually represent the people you're talking about, not just, a weird subset. Second, the analysis. Was it rigorous? Were the methods suitable? If they used something unconventional, did they explain why? Third, the overall study design. Was it the right kind of design experiments, simulations, surveys, whatever, for the question? Think about testing a new medical diagnostic tool. You need a decent sample size, right? And the right kinds of patient conditions. And finally, just clarity and detail. Does the method section actually tell you enough to understand what they did? If it's vague or leaves stuff out, that's a big warning sign. Because remember, a weak methodology, maybe an old data set, the wrong stats test, a fuzzy experimental plan, it just undermines everything, even if the idea seemed important and new.
Totally. If the process is flawed, the outcome is questionable. Which I guess leads us directly into the fourth question. Is the research actually verifiable? This seems like a cornerstone of science, right? Can someone else repeat it or check the findings?
Absolutely. Verifiability or reproducibility is huge. So how do you assess it? First, look for transparency in that methodology section again. It needs to be clear, like step-by-step clear. Details on data sources, the exact experimental setup, any parameters they use, the analysis procedures, all of it. Then look for supporting materials.
Yeah.
Nowadays, in many fields, authors provide extra stuff, datasets, code, detailed protocols. Are those available? Are they actually useful? Could you, or another researcher, realistically use them to reproduce the study? You're essentially asking, could someone else follow these instructions and get the same results?
Okay, so it's about leaving a clear trail.
Pretty much. Like a paper with a new algorithm. It's probably include the code, or at least pseudocode, right? And details about the testing environment, hardware, dataset specifics. Enough for someone else to try it. If those details are missing or the materials aren't there, it really makes you question the credibility. Also, sometimes results depend heavily on very specific conditions that are just hard for anyone else to replicate. That's another thing to watch out for.
That's interesting. I admit, I usually focus more on the big ideas, the results.
Yeah.
But I've definitely seen papers where the core idea seems great, but the paper itself is just hard to read, confusing. Which brings us perfectly to our fifth and final question. Is the research actually well presented? Does the communication aspect matter that much?
Oh, absolutely it does. You can have groundbreaking research, but if it's poorly communicated, it can just fall flat. Its impact gets lost.
Yeah.
So presentation quality is crucial. What do you look for? Well, clarity and structure first off. Is the paper logically organized? Does it flow well from the intro to the conclusion? Are the goals, methods, results, discussion all clearly laid out? Then look at the visuals. Tables, figures, charts. Do they actually help convey the findings? Or do they just muddy the waters?
Oh, I know what you mean. Like those graphs that are impossible to decipher.
Exactly. They should be clear, relevant, properly labeled. They should enhance understanding, not hinder it. And then there's just the writing quality itself. Is the text clean, free of distracting grammar mistakes, typos, awkward sentences? Poor writing really does undermine credibility, makes it harder to trust the content. And finally, a bit more mundane, but still important, did they follow the rules? Formatting, citation style, headings, page limits. It shows attention to detail. So yeah, a poorly presented paper can definitely obscure even really significant findings. It limits who reads it, who understands it, and ultimately its impact.
Okay, wow. That's a really comprehensive framework. So let's quickly recap for everyone listening. What does this all mean for you? We've walked through 5 key questions to ask when you're looking at a research paper. Is it important? Is it novel? Is the methodology sound? Is it verifiable? And is it well presented?
And the real benefit here for you is that by consciously thinking through these 5 aspects, you seriously sharpen your own critical thinking skills. You get much better at engaging with any kind of scientific or technical literature, not just formal papers. It's a process that obviously helps ensure the quality of published research, sure, but maybe more importantly, it massively benefits your own understanding, your own work, your professional development. You become much better equipped to make informed decisions based on solid evidence.
That's a powerful takeaway. So here's a final thought to leave you with. Think about how applying these 5 critical questions, importance, novelty, methodology, verifiability, presentation isn't just for academic papers. Isn't it really a powerful framework for evaluating almost any complex information you come across? A way to cut through the noise, figure out what's credible, and truly understand what matters.